This is something you need to know for today. The only thing you really need to know is this part right, y'all. When you have a function in standard form, which if you remember is ax squared plus bx plus c. If it's in standard form, that is the formula for finding your vertex, the x-coordinate of your vertex. And when it comes to any function, if you have an x-coordinate, how do you find its y? Plug it in. That's right. Just plug it in. So that's the reason I'm not going to ask you to write down this whole thing. All this says is, hey, there's your x. Plug x into your function to find your y. Hopefully your mind will just tell you to do that when you're doing your homework. So today we're going to be looking at quadratic equations in standard form. We're going to be finding our vertices, and to find our y value, we would just plug it in. Now, doesn't it make sense? We're going to be talking about maximums and minimums today. Isn't the vertex of a parabola always going to be that maximum or minimum value? Yes. So when the problems say, hey, what's the max or min? Plug in this to find where it's going to be, and then I'll tell you how to find out if it's a max or min in a second. And then to find the whole coordinate, you just plug that into the function, and there's the coordinate for your maximum or minimum. Okay. The graph of a quadratic function is given. Write the function's equations. So basically, we're just matching. F, G, H, or J. Number one, somebody take a gander. It may have been the Dom. Number one, F, G, H, or J. Very good, sir. Has a right shift of 1, has an up shift of 1. Now, this doesn't really pertain to what we just looked at in standard form, but if you were to FOIL all this out and then take that negative b over 2a, you would have found that 1, 1 is the coordinate of your vertex. But these, since we know our shifts, should be even easier. What about number 3? Where b is that one? You're right. Right shift of 1. Down shift of 1. Shebang. Raise your hand if you have a question about where we're getting those answers. Okay. All right. Now these are in standard form, so you're actually going to have to find your negative b over 2a. So what might be the easiest thing to do is to find our vertex on all of these, and then just see which ones match. Negative b over 2a on the first one. Negative b over, what's my a value? 1. So 2a is going to be 2. So my x-coordinate of my vertex is going to be negative 1. I'll just leave the y value blank for a second. Now, just looking at that, do either of these have an x-coordinate of negative 1 for our vertex? No, this one's 0. This one's positive 1. So f is out. Negative b over 2a, ooh, that one's 1. So it could be g for number what? Yeah, it could be g for number 7. Let's see. Now, what does this look like? If there's no g value, what can we just simply do with that? Don't think of it as a negative b over 2a. What's that function going to look like? Yes, it's just a parabola downshifted 1. Is that one of my options? Yeah, 5. We can go ahead and say these two are the same. That one's done. Now, what is this going to look like? That's right. It'll just be flipped. It'll look like this. Is there anything like that on here? No. So therefore, number 7 has to be G. It's the only one with a matching x-coordinate of the vertex. We didn't even need the y. Sure. Plugging in 1, you get 1 squared minus 2 times 1 plus 1. So that's 0. So your vertex is 1, 0. Now, here's how you're going to know, without having to graph these, the next slide, or one of the upcoming slides, asks you, does it have a maximum or a minimum? Here's how you know. If it's positive, then it's parabola going up, and you're going to have a what? Minimum. If it's negative, it's going to be going down, and therefore you're going to have a, okay then. So, that being said, let's just hop right in. Oh, it didn't even ask us for that yet. Find the coordinates of the vertex. Let's start on 13 and 15. Number 13, how do I find my x value? negative b, negative negative 8, over 2a. So what's that going to give me? 2. Plug that in to find your y value. 2 squared times 2 is 8, minus 8 times 2, plus 3, negative 8 plus 3, negative 5. There's that vertex. Is that going to be a maximum or minimum? Just ahead of the game. It's going to be a minimum because this is an upward breaking parabola, meaning it's going to have a minimum value. Negative b over 2a, that was the formula you wrote down. Negative b, so negative negative 8 over 2a, 2 times 2, 8 over 4, 2. 15! Negative b over 2a is going to give me what? I heard mumbles. Negative 1. And what's my y value going to be? Let's see, it'll be positive 1 made back into negative 1, plus 2 plus 8, so 9. And there's your vertex. 9 and 11 are actually even easier. Now you can FOIL them out and do all that if you want to, but where's my horizontal shift? On number 9, where's my horizontal shift? Right 3, where's my up shift? There's your vertex. If they're factored like that, then they're even easier. Where's my horizontal shift going to take me? Where's my vertical shift? And there's that vertex. You only even have to use that negative b over 2a stuff if it's in standard form. Now, like I said, you can FOIL them out and do them all the same if you want. Ooh, quick. Yes, ma'am. Good question. It is a negative, therefore it's going down, so it's going to have a maximum. So, real quick, 9, going to have a min or a max? Minimum, because it's positive. 11, min or max? 13 and 15. All right, super. We're almost done. Use the vertex and intercepts, the graph, to sketch the graph. You do not have to graph today. Give the equation of the parabola's axis of symmetry. Okay, well, that's stupid. I'll do one and show you what that is. That's really nothing. Use the graph to determine the function's domain, and so we're still not even in the max and mins yet. Dang. Well, you still don't have to graph, but I'm still going to show you what that would be. I'm going to do one of a prefactored one and one of a standard one. First, standard. Oh, dang it. I meant to have graph paper. This is not going to take 500 years. Did everybody have a good weekend while we're waiting for this to load? Oh, no, why not? You know, I think an alright weekend is actually an excellent weekend. I'm always telling my wife, have a very average day at work. Because if every day was a good day, then the average would change. Because, you know, average is the sum divided by the total. So then a good day would be an average day, and everything would look crappy that was actually average. So if you have an average day most often, good days will seem good. So you had a good weekend. Anybody who had a good weekend had a great weekend. See, it's like a sum theorem. Anyway, and that's applying pre-calculus to life. Don't say I don't teach you stuff. Okay. Oh. But it'll make other weekends look all the better. Okay. So, here we go. Graphing. Easiest thing to graph on both a line or parabola or any function. What is the only number in that function without a x on it? Negative 10, which means way down here at negative 10 is going to be your y-intercept. Might as well go ahead and plot that. Well, I'm going to have to slide down. I'm not going to have enough room. My parabola, negative b over 2a, is negative 3/2. So, and to find, oh, really? Fraction, first problem? That's not cool. Finding my y value. Oh, okay, finding my y value. That's going to be, oh man. Ugh. Plugging in negative 1.5 into the function. That's going to be 9/4 minus 3/2 times 3 Negative 9 halves minus 10. Oh man, this is really ugly. 9 fourths minus 18 fourths minus 40 fourths. 9 minus 58, negative 49. Negative 49 fourths, which is negative 12 and a fourth. So coming all the way down here in a fourth, that's here-ish. There's your minimum. There's your vertex. Go through your y thingy, make it symmetrical, and there's the graph. Not perfect, but there you go. Now, it says find the axis of symmetry. The axis of symmetry is stupid because on all parabolas, they're all symmetrical around their vertex. So whenever you find the vertex, you've actually found the axis of symmetry. The vertex is this, and the axis of symmetry would be the line x equals negative 3 halves. This imaginary line right here. Well, it's straight in a world not like this one. Whenever you see axis of symmetry, don't fret about it. It's nothing more than your x-coordinate of your vertex made into a linear equation. You know, I'm going to say yes, just so you can get used to how easy they are. Because if one pops up on a test and I don't make you do it, people are going to freak out like, oh, remember that. But it's so easy, might as well get the hang. So, today, you do not have to graph, but I do want you to answer everything. Didn't it also say what's the domain and range? How can we do that without graphing? Well, what's the domain of every single one of these going to be? That's a much easier way to say it. Very good. All real numbers. Now, the range. Figure it out. Is this going to have a minimum or a maximum? It's going to have a minimum, which means your range is going to have a bottom, but not a top. So it's going to go to positive infinity. Where's it going to bottom out? That's going to be the y value on your vertex. So the range on this particular problem is going to go from negative 49 fourths to infinity. And you can simplify that if you want to. Let's do another one, but without graphing. Okay, let's see. We'll do a pre-factored one and a not factored one. How about this one? That pair. Number 19. Let's do that one first. It asked us for the no. It asked us for the vertex. What's the vertex of this here problem? Yes. Right shift of 1, up shift of 2. What's my axis of symmetry? X equals 1. It's always going to be the same thing as this number every single time. If you find your vertex and the axis of symmetry is literally staring you in the face. Then just domain and range. What's the domain on all of these going to be? All reals. Now, is this going to have a max or a min? It's going to have a min because it's positive. So it's going to have something to infinity. What is that something? Very good. 2. And we're done. So we have vertex, axis of symmetry, domain, and range. If you were to graph this, what would the y-intercept be? Actually, that's a little tricky. Never mind. I didn't ask that. 31. Vertex. How do I find it? Negative b over... Oh, this is in incorrect order. Rewrite it so that it's in correct order first. They did trick me too. Negative b over 2a. What's my y value going to be if I plug in 1? 2 minus 1 plus 3. Is that 4? What's my axis of symmetry? What's my domain? Very good. And my range? This is going to have another minimum. I'm so dang proud of you guys. Now, if it were to have had a maximum, then it would... if it were to have had a maximum, then it would just be negative infinity to whatever that thing would be. But none of these apparently have. Let's find one with a maximum. Anytime it's positive, that means it's going up, so it's going to have a minimum. Ah, yeah. Shut it. Okay. I may be wrong a lot, but at least I can admit it. Thank you, Ashton. You are correct, sir. It has a minimum at negative infinity. I mean, it has a range of negative infinity to 4. Questions? Judging by the level of talking, I'm guessing not. Finally, a max or min problem. A, determine whether it has a min or max value. We can do that. Find the min or max value and then find its domain and range. Cakewalk. 41. Is it going to have a min or a max? Part B, what is the max? Vertex. 1 comma, whoa, that's what? And how do I find my y value? Negative 4 plus 8 is positive 4, minus 3 is 1, 1. And domain and range, what's the domain going to be? All reals. And the range? So dang proud right now. That's correct. That is correct. Raise your hands if you have questions about where we came up with any of those answers. Yes. I'm sorry. 39 or 43. Pick your poison. 39. Okay. First things first. Maximum or minimum? Is it positive or negative? It's positive. Thus, because it's positive, what's it going to have, Latifa? It's going to have a minimum. I know it's like saying cinnamon. I always mix it up. Cinnamon. Okay. Finding Nemo, great movie. The max or min is going to lie where? Rhymes with Smurf text. The vertex. Negative b over 2a. How do I find the y value? 2 squared is 4. Times 3 is 12. 12 minus 24 is negative 12. Negative 12 minus 1. I will stop for a moment, let people write that down. But just plug in your x value once you have it. Now, Sarah, what's the domain of all of these going to be? All reals. Now, because it had a minimum, means you're going to be something to positive infinity. Very good. Negative 13 to infinite. Other questions? Yes. Actually, let me see what the next slide is. Nope, never mind. Yes, I will. Let's do 43. Let's do 43. Senior McAdams, am I going to have a min or am I going to have a max? That's right. You got one thing right, don't flaunt it. Justin, how am I going to find where that minimum be? So 5 over 10, I don't know why I wrote it like that, equals 1/2. Negative, well, it's already negative, so negative and negative makes it positive. And then plugging that into the function, 1/2 squared is 1/4. 5 times that is 5/4. Minus 5 times 1/2, which is 5/2. What is 5/4 minus 5/2? So impressive. That's right. And you could do that in the calculator for right now too. 5/4 minus 5/2 when you plug the 1/2 into the function is negative 5/4. Muy impressivo. Yes, ma'am. Right here? Like, I mean, you're asking where I got that one from? Okay, we plugged 1/2 into this function. 1/2 squared was 1/4. 5 times 1/4 was 5/4. And then we plugged 1/2 into this x. 5 times 1/2 was 5/2. So that gave us 5/4 minus 5/2, which I believe Ryan answered was negative 5/4. That's where that came from. When in doubt, you can always punch this into your calculator. That's 1.25 minus 2.5, which is negative 1.25. What's the domain going to be? And what's our range? Now it's a minimum. Very good. Negative 5/4 with a bracket to infinity. Is there a question on that? Yep. Or your maximum, depending on which one you have. But it'll always be that. The only thing that'll change is whether it's the positive or negative infinity. Good question. No. Well, not today. Really not until calculus. Other questions? We only have one more slide. Hey, guys, knock it off. I like questions. 45. The vertex is and the parabola opens up. So, if it opens up, that means we had a what originally? We had a minimum. It says give the domain and range. So if we had a minimum, then our domain's automatically going to be. But if we had a min, that means our range is what? Very good. Whoever y'all's algebra and trig teacher was, if you had that class, did a really good job. 47. It has a maximum. Now, I don't know why they wrote it like this. This is really just the coordinate 10, negative 6 is where the maximum occurreth. So, the domain is... Wow. It's exciting. And the range is... Very good. All it's asking for is the domain and range. So really the only thing you had to know here was whether to put this as a maximum or a minimum. Hey, we just went through 22. Well, that's not true. The test is part of it. Never mind. Questions? There you go. Yes, you can go now. Okay, you go.